think the emergence of of generative design. I mean, I think that's like as a designer, those are the questions that we have. But I think that it's in some ways the tool as these. I mean, it's a double-edged sword. The availability of computation. I mean, Voronoi is the perfect example. You know, the ubiquity of Voronoi and like the fact that it's now a joke. You know, it's now a punchline as if it's Voronoi. You know that it's a joke. But you know, back in the early part of the 2000s, creating an algorithm that could actually compute Voronoi represented a real achievement.
That was sticking on a facade, using it as an urban plan, using all these things.
Yeah, that was like an achievement of implementation. And all these, you know, Galapagos, the sort of original evolutionary solver for a design interface, you know,
in a mainstream design interface that was really easily implemented.
Totally. And I think that once a certain kind of type of architectural designer that's really interested in parametric design and computation and these kinds of explorations got their hands on these things, that's when a lot of this started to come. It was and you see it all the time. I mean, this is another issue with machine learning. There's the solution in search of a problem to solve. And all of the optioneering and evolutionary solvers and these kinds of heuristics have been in use in engineering for ages. And it's great for very targeted tasks. So you have a very specific problem, and you don't know the best solution, or at any event, arriving at an ideal solution for you is going to take a while.
But
so you
know
basically
how to measure the correct solution. Like you know how to quantify it numerically in some way.
It is very quantifiable. I mean, that's what makes engineering stuff work really well. Or, I mean, you know, I can give a personal example. Years ago now, this was in 2010, working on building and doing detailing work, basically orienting steel that would not clash and would be using as little material as possible and would work structurally. I just had in
a very complex building.
In a very complex
building.
Which is the Louisiana
Museum and Sports Hall of Fame.
Yep.
To solve that geometry problem would have been very painful for someone.
Absolutely. And it was really targeted for these moments where there was very little space and had to get the steel in there. And for me to like spin the sliders around and to find an ideal solution would have been a pain in the butt. But the problem was so well defined. It was so clear what the boundaries of the problem were. And it was perfect for that. Those kinds of search heuristics are amazing when the problem is incredibly well defined. When you have these really open-ended problems, and you know, going back generative design,
right.
It's essentially at its core, those are the first things Dreamcatcher and this they're doing essentially like a form of evolutionary solvers. It's basically heuristic searches, as you said, optioneering, these kind of really well-established terms for sort of identifying a variety of options and then exploring them systematically, either through brute force or through some kind of search heuristic.